Okay, so we're going to continue our study of quadratics, and today we're going to find the vertex. All right, so let's talk about what you already know. So, standard form, ax squared plus bx plus c. We know the y-intercept is the point where the graph crosses the y-axis. We find this by setting x equal to 0 and solving for y. When a quadratic is written in standard form, the y-intercept is the point 0, c. The x-intercepts are the points where the graph crosses the y-axis. We set y equal to 0. We've been factoring and then solving for x. And we looked at if my factors are x minus 1 times x plus 3, then my x-intercepts are the points 1, 0 and negative 3, 0. Because we have to think our intermediate step is setting each factor equal to 0 and solving for x. So those check for understandings that you had to do, my factors and my x-intercepts, they're opposite signs of each other. Okay, the vertex is the highest or the lowest point on the graph of the quadratic, and we know the graph is called a parabola. So when a is greater than 0, my parabola opens up, and the vertex is the minimum point. When a is less than 0, when my lead coefficient is a negative number, my vertex is a maximum. It's the greatest point on the graph. Okay, so min and max are all about the behavior of the lead coefficient, that value of a. All right, and you should have taken notes on this already. Axis of symmetry, it's a vertical line through the x-coordinate of the vertex. So if this is my vertex, if I draw a vertical line through my vertex, then whatever's on the left-hand side of that line is exactly symmetrical to what's on the right-hand side. Okay, so let's work on finding the vertex. So the vertex is, most generally, we use the ordered pair h, k to represent the vertex. So the x-coordinate is the h, y-coordinate is the k. To find the x-coordinate, your x-coordinate h is equal to the opposite of b over 2a. Well, where do these values come from? Well, where have we seen a and b? So a is our lead coefficient, the number before the squared term, and b is the coefficient to our x term. So that's how we find our x-coordinate, the opposite of b divided by 2a. Well, where does our y-coordinate come from? Well, think about this. If I tell you I have a value for x, let's say x is equal to 1, where does my y value come from? I have to plug it back into my function. That's all that this says, f of negative b over 2a. That means I plug my x-coordinate into my original and find y. Okay, that's just function notation. So that's a much simpler way of than writing this out every time. So let's look at some examples. So find the vertex and the axis of symmetry. Now let me go back to this. So if this is how I find my vertex, then my axis of symmetry so let me go back to my notes here. The axis of symmetry is the vertical line through the x-coordinate of the vertex. Okay, vertical lines are always written in the form x equals, and if it goes through the x-coordinate of my vertex, the x-coordinate of my vertex is that value of h. So the axis of symmetry and the vertex are directly related. You can't have one without the other. So the three examples we're going to do, we're going to find the vertex, and then I'm going to show you just how easy it is to go right to the axis of symmetry. Okay, so when I look at this function, a is equal to 1, b is equal to 6, c is equal to 8. Why is a equal to 1? Because I know when a number is not written in front of the x squared term, it's known to be 1. Okay, so my vertex. my x-coordinate, okay, so h comma k, my x-coordinate, the opposite of b divided by 2a. So the opposite of positive 6 is negative 6 divided by 2 times 1. Now, if you're using a calculator, you just have to be aware, and I would tell you to multiply the denominator, right? So my x-coordinate would be negative 3. Where does my y-coordinate come from? I take my x value, and wherever I see an x, I replace it with negative 3. Okay, where did that negative 3 come from? Because that's the x-coordinate of my vertex. So how do I find my y? I plug it back in. So this gives me 9 minus 18 plus 8. 9 minus 18 gives me negative 9. When I add 8 to that, I get negative 1. So what's my vertex? My vertex is an ordered pair. It has an x-coordinate of negative 3 and a y-coordinate of negative 1. Okay, so what's my axis of symmetry? My axis of symmetry is always a vertical line, and it's always through the x-coordinate of the vertex. So that negative 3, it's very important. Look at all the places we use that negative 3 value. Okay, find the vertex and axis of symmetry. A is equal to 2, B is equal to 4, C is equal to 5. So notice we don't use the value of C to find the x-coordinate of the vertex, but we do need it when we go back and plug in to find the y. So the vertex is the ordered pair h comma k. H, opposite of b, divided by 2a. B is equal to 4, so negative 4 divided by 2 times a. Negative 4 divided by 4, so my x-coordinate is negative 1. My y-coordinate, wherever I see an x in my original problem, I'm going to replace it with that negative 1. Where did negative 1 come from? That's the x value. That came from negative b over 2a. So this is equal to 2 times 1 minus 4 plus 5. 2 minus 4 plus 5. So I get negative 2 plus 5. So I get a y value of 3. So my vertex, x comma y. My axis of symmetry, it's always a vertical line through the x-coordinate of the vertex. Oh, I kept that one the same. Sorry about that, I copy and pasted and never changed the problem. So change number 3 to y is equal to negative 3x squared minus 12x plus 1. Okay, so looking at this quadratic, my lead coefficient is negative 3. My value of b is negative 12. My value of c is positive 1. So the x-coordinate of my vertex, opposite of b divided by 2a. The opposite of the value of b. So my b value is negative 12. So what's the opposite of negative 12? That'll give me positive 12 in the numerator. All divided by 2 times a. 2 times negative 3 gives me negative 6 in the denominator. So what's 12 divided by negative 6? My x-coordinate will be negative 2. Y-coordinate of my vertex, negative 3 times x squared minus 12 times x plus 1. What's my value of x? That's what we just solved to be negative 2. So I'm going to plug that back in. So negative 3 times 4 plus 24 plus 1, negative 12 times negative 2. Negative 12 plus 24 plus 1. Negative 12 plus 24 gives me 12, plus 1 gives me positive 13. So my vertex is the ordered pair negative 2 comma 13. My axis of symmetry, it's the vertical line through the x-coordinate of the vertex. You have to be very aware of what this means. It means the opposite. So on the two previous problems, when b was a positive number, the opposite of b became a negative number. So when b is already a negative value, when you take the opposite of a negative, it makes it positive. Okay, so there's things that you just have to remind yourself of. Now let's put it all together. So sketch the following. Okay, so what are all the things that we have talked about? We've talked about the y-intercept, the x-intercept. Now we can find the vertex and the axis of symmetry. All right, so when I look at this, a is equal to 1, b is equal to 1, c is equal to -6. Now right from here, my a value is a positive number, so I know that my parabola has to open up. Okay, so there's certain things that we already know about the quadratic and what the graph should look like that our math needs to support. Okay, so first we'll start with the y-intercept. So for the y-intercept, I set x equal to 0. Okay, so wherever I see an x, I replace it with 0. All my zeros go away, so y is equal to -6. And that's what I started the video with. In standard form, your y-intercept is just 0, your value of c. My x-intercept, I set now y equal to 0. Okay, so wherever I see y. All right, well now my next step would be to factor. Because a is equal to 1, I need two numbers that multiply to -6 and at the same time add to +1. So 3 times -2 gives me -6. 3 plus -2 gives me +1. So my factors are x plus 3, x minus 2. So I take those factors, I set them equal to 0, giving me two mini equations. Okay, so now my x-intercepts are the points -3, 0, and 2, 0. All right. Next is my vertex. So the x-coordinate of my vertex, the opposite of b, all over 2a. So the opposite of b is 1, all over 2 times a is equal to 1. So my x-coordinate is -1/2. So now to find my y-coordinate, I have to take a -1/2 and plug it back into my original. Pause the video, take your calculator out, plug it in exactly as I have it written, and see if you get the same answer as me. Okay, so down here I had to write out all the math, but if you have your calculator, you should have gotten a y value of -6.25. If you didn't, go back and make sure you put this -1/2 in parentheses before you squared it. Okay, so lastly, my axis of symmetry. My axis of symmetry is the vertical line through the x-coordinate of the vertex. All right, so if I have all these points, I have what I need to graph. Okay, so I have x-intercept 2, 3, 4, 5 at -6. 1, 2, 3. X-intercepts at -3 and 2. My vertex is at -1/2, -6 1/4. So my vertex is really close to the y-intercept, but it needs to be a little bit below because remember on this graph, my vertex better be the minimum. It better be the smallest point on the graph. Now your axis of symmetry, I can sketch that in just so I'm making sure that what's on the left-hand side is the same as what's on the right-hand side. Now sketching these by hand, these are exactly that. They're sketches. But I would expect to see those points. Okay, that'll do it for this video.